Okay, hello Cloud Gurus and welcome to this lecture. Congratulations, you're at the very end of the DNS section. I know DNS is not the most exciting topic in the world, but you do definitely need to know it to be a solutions architect in real life. Now, like I said, I did the exam just a couple of weeks ago and I didn't get any Route 53 questions, but I have been doing the exam for 5 years and it usually does come up pretty heavily. So it is definitely something that you need to know, and I wouldn't be surprised if I just got a weird bank of questions. I'm actually going to go do another exam in a couple of weeks' time and see if I get Route 53 questions. So let's cover off what we've learned, my Route 53 exam tips. Now, always remember that elastic load balancers do not have predefined IPv4 addresses. You resolve to them using a DNS name. I appreciate we haven't covered off elastic load balancers much yet in the course. We will get that when we move on to the highly available section of the course. And ELBs or ELBs, ALBs, whatever it is you want to call them, they are extremely important topic for the Certified Solutions Architect Associate exam. You should definitely understand the difference between an alias record and a CNAME. If you just remember that yellow pages picture that we had up, so we had all our A records, which was just people's names and then their telephone numbers, and a CNAME was that Bruce Wayne, or I think it was Batman, and then it said C. Bruce Wayne. So that's exactly how a CNAME works. And then given the choice between an alias record on a CNAME in an exam scenario, I would always choose alias. Most of the time, Amazon are going to be asking things like your naked domain name. You need to map your naked domain name or your zone apex record to an S3 bucket. What should you be using, a CNAME or an alias record? Well, you want to be using an alias record. And we're going to see how to do that in the serverless section of the course. So some common DNS types, we've got our start of authority record, our NS records, our A records, our CNAMEs, our MX records, and our PTR records. And the following routing policies are available with Route 53. So we started off with simple routing. We then looked at weighted routing, latency-based routing, failover routing, geolocation routing, geo-proximity routing, but we had to do that using the traffic flow, and then multi-value answer routing. We also learnt all about health checks. So you can set health checks on individual record sets. If a record set fails, a health check is going to be removed from Route 53 until it passes the health check again, and you can set up SNS notifications to alert you if a health check has failed. So simple routing, if you choose simple routing policy, you can only have one record with multiple IP addresses and you can't have any health checks. If you specify multiple values in a record set, Route 53 will return the values to the users in a random order. So here's our user, they're typing in a DNS address. Route 53 is giving them the first record and then it's giving them the second record, but we can't have a health check on that one. Weighted routing policies, we've got our user, they're typing in a DNS address and we're setting weights. So we're sending 20% of the traffic to US East 1 and 80% of the traffic to US West 1. So that's how weighted routing traffic works. Latency-based routing is based on our user's location and the latency. So our South African user is going to visit our website. It's behind Route 53 and essentially they're going to get 54 milliseconds if they use US West 2, 300 milliseconds if they use AP Southeast 2. So of course Route 53 is going to send them to the fastest fleet of EC2 instances first, which is going to be EU West 2. Failover routing, this is where we start using our health checks. So essentially we've got an active passive environment. Our active environment could be US West 2 and our passive environment could be AP Southeast 2. If for some reason our EC2 instances or a region goes down, it's going to detect this using a health check and it's going to fail over to our passive environment. Geolocation routing allows our European customers to be sent to our European servers, and it allows our US customers to be sent to our US servers. It doesn't have anything to do about latency. It actually physically knows where our customers are, and then it makes routing decisions based on that we configure. So that's how geolocation routing works. Geo-proximity routing, as you saw, we could start going down the rabbit hole. This is an advanced networking specialty topic. It is not something that comes up in the Solutions Architect Associate exam or even in the professional exam, but it allows you to create route traffic to your resources based on the geographical location of your users as well as your resources. And to use geo-proximity routing, you must be using Route 53 traffic flow. And then finally, we had our multi-value answer policies. And essentially, this is the same same as simple base routing, except you get health checks. And so you can have multiple values within your record sets. So we've got our record set in here, and we've got our first and our second. And if one fails a health check, what's going to happen? Well, it's going to remove that from the record set, or it's going to stop serving that record until it passes the health check. So that is it for this section of the course. You've done very, very well. The next section, we're going to learn all about VPCs, and that is crucial to passing your Certified Solutions Architect Associate exam. And it is actually an awful lot of fun. So if you've got the time, please join me in the next lecture. Thank you.